Hello and welcome to another video. So this video I'm going to be doing a quadratic function or using a quadratic function in finding an integral using the definition of the integral. So here we're not going to be integrating. What we're going to be doing is, well, we will be finding the value of this definite integral using the definition of the integral. Okay? And I'm going to make you understand, if you did not understand, what exactly this means. Okay? In the first video that I made about this, it had a linear function. This is a quadratic. I explained the entire concept of the Riemann sums. So we're going to be doing the Riemann sums of this. I just want you to know what this means and what this means. In this video, I already explained it, so you might watch the other video because I did a longer explanation. So this, I'm just going to solve it. Okay. So what does this mean? Well, if you did the usual integration, you're going to get 24. So we're looking forward to getting 24 when we do our Riemann sum explanation. So what exactly is delta x and what is f of x sub I, and how do you use them? Okay, so the first thing you must know is that the delta x simply is the width of each of the rectangles you're going to be using. So if you're using 10 rectangles, it's going to be the gap you're going through divided by 10. If you're using 1 million rectangles, you'll be dividing by 1 million. If you're using n rectangles, you'll be dividing the gap by n. Okay, and that's what we're going to say. We're going to say delta x, which is the width of each of the rectangles we're using. Let's say the function goes like this, and you're using so many, but all these rectangles have the same width. That's what you call your delta x. Okay, it's going to be definitely the gap from, let's say this is the end and this is the beginning. It's going to be the ending minus the beginning, this space divided by the number of rectangles, 1, 2, 3, 4, 5, 6, 7. So here it's going to be b minus a divided by 7. Okay, but if you're using an infinite number of rectangles, you just divide by n and you say n is going to infinity. Okay, which is what we're going to do here. So delta x will be equal to b minus a divided by n, okay, which in this case our b is the upper limit boundary and the a is the lower boundary. So this is going to be 5 minus -1 over n, which is going to give us 6 over n. So we need this. This is important, okay? It is actually the most important thing that we need right now, because that's the only thing we didn't know. Now, what else do we need? This is a strange expression. So x sub I means each of these points. So the first point you're starting with is what we call a. That's the beginning. The next point is simply a plus delta x, because you've moved delta x to the right. So every point here, apart from the beginning, is going to be a. Then the next one is a plus delta x. Then the next point is a plus delta x plus another delta x. So that's a plus delta x times 2. This is times 1. The next one is going to be a plus delta x times 3, because you have to move 3 steps. Delta x, delta x, delta x, 3. So you see that you're just going from 1 delta x to 2 delta x to 3 delta x to 4 delta x. How many delta x's do you need? Well, it depends on how many rectangles you have. That's why our I is changing from 1 to n. Okay, so if you're just using 5 rectangles, then it's just going to be, your n is going to be 5. But if you're using an infinite number of rectangles, your n is going to go from 1 and approach infinity. And that's basically the idea of this. And the more rectangles you have, the more accurate your answer will be. That's the beautiful thing about Riemann sums. So let's find our x sub I. Well, x sub I is always a plus delta x multiplied by I. So how many i's do you need? Sorry, how many delta x's do you need depending on what the number of rectangles, which is the I. So basically you have this, you have this. Let's transform this, because we already know what delta x is and we know what a is for this problem. A is going to be -1. Okay, And delta x, we already know it's going to be 6 over n multiplied by I, which we can write neatly as 6 over ni minus 1. So this is another thing we want to keep in our minds, okay? So now let's solve the problem, since we have the two most important things that are in the formula that we have. So the next thing you want to do is write this and say, hey, I know that from -1 to 5 of x squared minus 2x plus 1 delta x is going to be the limit as n goes to infinity of, it's going to be this. But everywhere you see, so we're going to write this I equals 1 to n of the function. But everywhere you see x, so you see this is not f of x, it's f of x sub I, you're going to replace x with x sub I. Okay, so this is what we have. We're going to have x sub I squared minus 2 times x sub I plus 1 multiplied by delta x. What's delta x again? It's 2 over n, 6 over n rather. So, but let's just write this as delta x. So now we're going to substitute everything here and make it look, it's going to look weird at first, but it works. This is equal to the limit as n goes to infinity of the sum from I equals 1 to n of, now what is x sub I? We said it is 6 over ni minus 1 squared minus 2 times 6 over n I minus 1 plus 1. Okay, we have just written our f of x sub I. So all of these will be multiplied by, what is delta x? 6 over n. Beautiful. So you can put this in parentheses too. Okay? Now, that's all. If you can do the algebra following this line, you have simply integrated or evaluated this definite integral. So let's do that. Let's continue our algebra, know what these mean, and simplify them. So this will be the same thing as the limit as n goes to infinity. I'm going to distribute this. So I'll do the rough work here and then transfer it there. Okay, as let's see, as of I equals 1 to n. And don't be tired of writing this because that's the only correct expression. You have to write it that way. Now, what happens when we distribute this? Let's do 6 over ni minus 1 squared. By the way, remember this I is not an imaginary number. It is not equal to the square root of -1. So don't let your mind go there. This I is representing changing integers. So we're saying that you need 1 and then you need 2 and then you need 3. So I is changing from 1, 2, 3, 4, 5. So it's a notation for the summation. So do not think it's an imaginary number. Okay, so if we have this, this is going to be 6 over n I minus 1 times 6 over ni minus 1. If you FOIL this, you know your answer is going to be 6 over ni times 6 over ni is going to be 36 over n squared I squared. Okay, you would say, why am I not putting the I on top here as 36 I squared? You could do that, but there's a reason why I want to leave it on the side, because we're going to replace the I squared later. Okay, so at this point, I have the first foiling, that's what it gives me. And then when I do this times this, is going to be minus 6 over ni. And then this times this gives me minus 6 over ni. And then this times this gives me plus 1. So you notice that if I clean this up, it's going to be 36 over n squared I squared minus 12 over ni plus 1. So this is what's going to fit here in the first gap. I'm going to write it. It's going to be 36 over n squared I squared minus 12 over ni plus 1. I've taken care of the first one. Now the second one doesn't need any elaborate calculation. I just need to multiply. 2 times 6 over ni is going to be 12 over ni. That's minus 12 over ni. And then minus 2 times minus 1 is going to be plus 2. Okay, now let's go to the last one. It's going to be just plus 1. Okay, plus 1. Remember, all of this will still be multiplied by 6 over n. Okay, I'm still multiplying by 6 over n. Multiplication. Okay, now let's clean up what's in the middle here. What do we have? Let's see. This is going to be the limit as n goes to infinity of the sum from I equals 1 to n of, well, this one is just alone, so we're still going to write 36 over n squared, I squared. Now this and this look the same. They both have I, so it's going to be minus 24 over ni. And then 1 plus 2 plus 1 gives us plus 4. Still multiplied by 6 over n. Okay? I think the next line is going to bring in this 6 over n into each of the terms. So this is the limit as n goes to infinity of the sum from I equals 1 to n. If I multiply this by this, I'm going to get 36 times 6 is going to be 216 over n cubed I squared minus, this is going to be 6 times 24 is going to be 72 times 2, that's 144. So it's going to be 144 over n times n is n squared. You have I plus, this times is going to be 24 over n. Okay, we're done with that. So something interesting is that you can actually break these into different sums so that you can take the summation sign, use it for this, put another summation sign here, put another summation sign here. Okay, so this line can actually be, and by the way, this is not changing. What's changing is the I. This I simply means I'm going to explain each of these. So let's write one more term. Okay, let's write one more term. So here I can say this is the same thing as the limit as n goes to infinity of, I'm going to now divide all of these into bits so that this is going to be the sum of, let's go, I equals 1 to n of 216 over n cubed I squared minus, so I'm taking all of the limits, minus, I create another one, the sum, okay, from I equals 1 to n of 144 over n squared of I plus the sum from I equals 1 to n of 24 over n. Okay. Now it's important that you know what this is. So at this stage, you see this 216 over n cubed, you can take it to the back because this is the I that's changing. You can take this to the back also here because this is the I that's changing. And this one you can take it to the back and what you have left is just 1. And I'm going to explain what each of these summations will mean in reality. So let's write one more line. This is going to be the limit as n goes to infinity of, so now I'm going to have 216 over n cubed, then the sum comes in, I equals 1 to n of I squared, okay, minus, I'm going to have 144 over n squared, then the sum from I equals 1 to n of just I plus 24 over n of the sum from I equals 1 to n of just 1. So assume you have factored out, okay? You've factored out 24 over n. Here we factored out 144 over n squared and we have I remaining. Okay. Now what do these all mean? Let me explain each of these, okay? The first expression you see here, I'm going to use, let me use the blue chalk. This expression, I equals 1 to n of I squared simply means when I is 1, I am going to have 1 squared. This summation sign means I'm going to keep adding, plus. When I is equal to 2, I'm going to have 2 squared. When I equals 3, I'm going to have 3 squared. I keep going until I get to n squared. Now this is the sum of the first n squares. Okay? Now there's a formula for this. Well, you should have learned this in algebra or pre-calculus, and otherwise your professor is going to provide this for you, but you should know it. The sum of the first n squares can be written in short form as n into n plus 1 times 2n plus 1, all divided by 6. So this is what you expected to use to replace this expression here. Okay, so this expression that I just dotted around can be replaced by this. And even a cleaner way or a more efficient way to write this is to distribute everything, and you're going to end up with this expression. It's going to be 2n cubed plus 3n squared plus n over 6. This is what I'm going to use now, because if you distribute this, this is what you're going to have. So I'm going to go back here and replace this expression with this. Okay? Okay, okay, let's do it. So that's what happens with this one. Now let me talk about this one. You see the second expression, this one here, I equals 1 to n of I, it simply means when I is 1, you write 1. When I is 2, you write 2. When I is 3, you go on until you get to n. The sum of the first n numbers is like someone asking you to add all numbers from 1 to 10. Well, you quickly do 1 plus 2 is 3, 3 plus 3 is 6. That takes forever. Not forever, but not as fast as you're using the formula, which tells you that this can be written, let's use the red marker, okay? That this can be written as n into n plus 1 over 2. So you have to know this. This is pre-calculus or algebra 2, okay? So with this, you can write this as n squared plus n over 2, and that's what I'm going to use to replace this. Okay, let me explain what this means. What does this mean? If you have the sum I equals 1 to n of 1, what does that mean? It means when I is 1, well, this is not I, this is 1. You're going to have 1. When I is 2, you're still going to have 1. When I is 3, you still keep having 1. So you're going to have 1 how many times? Well, it depends on what I becomes. If I becomes n, then you're going to have you're going to have 1 n times. So what is 1 times n? It's just n. So because this is a constant, we're going to replace this with n. Okay, now you've seen all my explanations. This is going to be equal to n. This is going to be equal to n squared. Nicer way is n squared plus n over 2. And nicer ways to write this. So I'm going to go back here. The next line, I'm going to replace everything I have written here, here, here with these three expressions, and we'll get our answer, because we're just going to take the limit and the answer is just going to pop out. Whew. Okay, let's do this. So this is equal to the limit as n goes to infinity of 216 over n cubed multiplied by this expression can be written as 2n cubed plus 3n squared plus n over 6 minus this expression is 144 over n squared multiplied by this expression can be written as n squared plus n over 2, and the last one is plus 24 over n multiplied by n. Now, because you've all learned how to take limits, this is so easy to do, because firstly, we can clean up these and say this is the limit as n goes to infinity of, I'm running out of space, but I'm sure the next line will be the answer. Okay, so the limit of, now let's see, This 6 is going to divide 216, and you're going to have, so let's go. 6 divides, so we're going to split each of these, or we don't have to, okay? 6 divides 216, you're going to have 36, okay? So you're going to have So now I'm going to do many things together because I'm running out of space. But if we clean up these expressions and divide each of them, we know that 6 will divide 216, okay? 6, if we clean this, okay, let's clean this up. Let's clean this up. Let's do it. Let's do it here. I need to find a space. Okay, I'm going to do the cleanup for each of these terms and then fix it. So let's start with this one. 6 is going to divide 216 and you get 36. Okay, so we're going to get 36. Let's use the blue marker. We're going to get 36. Okay, so n cubed, so this 6 is gone because now we have 36. Okay, now n cubed will divide 2n cubed. So 36 times 2 is 72. N cubed divides n cubed. You have just 72. So for the first expression, we have the limit as n goes to infinity of 72. For the second part, okay, we have n cubed is going to divide this. You're going to have n squared over n cubed is going to give you just n under. And then you're going to have 36 times 3. What would 36? No, because 3 already divides this, so this 6 is gone, okay? So 36 times 3 is 108, so it's going to be plus 108 over n. That's the next one. The next one is going to be 36 plus 36 over n squared. Okay, we're done with this part. We go to the next one. This is going to be, this 2 will divide 144. You're going to get 72. Okay, and this n squared will divide this n squared. You're going to have nothing. So it's just minus 72. Now this minus distributes over this. Maybe I should have put this in parentheses. Okay, so this minus will make this a minus. So that is minus. And because, so we have 72 times n. So that's 72 over n. That's what you're going to get here when you simplify. And the next one is going to be plus. This n cancels this n, is just 24. Okay, so now let's take the limit. As you can see, as n goes to infinity, everything that has n in the denominator will go to 0. So this goes to 0. This will go to 0. This will go to 0. What is left is 72 minus 72 plus 24. So this is equal to 72 minus 72 plus 24. And that's equal to 24. Wow. We survived. So you see how precise it is? It's the same answer you would get if you just do your regular integration. So it just takes some algebra and it takes your knowledge of these sums. Make sure you know what these mean. I'll see you in the next video. Don't stop learning. Those who stop learning have stopped living. Bye-bye.